thanks very much, Fergal, for taking the time to talk to us today. I was thinking we could start with, do you remember when you first became interested in computer science and technology?
Yeah, I've been interested in technology for a long time. I remember there was a girl I was in secondary school with when I got interested in technology, probably maybe second or third year in secondary school. She said, "Oh, on your first day you told me you wanted to be a computer programmer." And so I was at least as interested in it from the start of secondary school. I did some kind of computer programming in secondary school. I used to play video games, and I was trying to like mod video games, and I sort of like learned the dialect of C, kind of doing that, and kind of got from there into like teaching myself C. And I went to the Young Scientist exhibition with some probably really bad C code that I wrote to do cryptography stuff. And so, yeah, I've been interested in it for a long time. Love technology. I think it's great, and I'm just excited that I get to work on it day by day.
Yeah. And did you self-teach yourself that programming, or was there someone at home who was interested in the area, or?
I have an uncle who worked in technology, and he did computer ops in DCU way back when, and so he had some old, literally C textbooks kind of lying around, like a really old C textbook by Q. I think it was probably a course book in DCU, and I just started working through that on like a computer on a PC, and I was lucky enough to have a PC, and that was kind of frustrating going. And I think I got a copy of like C for Dummies at some point as well, which is a much more gentle introduction. And I remember being in like work experience in transition year. I got a job like assembling bits of computers, like literally, manufacturing, like putting GPUs into computers, and got a job doing that. And I remember like reading through C for Dummies in the evenings in work experience in the spare bedroom in my aunt's house in Dublin. So it's I taught myself, and I was really interested in it. And then a bit later, I got access to the internet. It's probably like 96 or 97 or something like that, and really 14.4 dial-up access to the internet, and then there's a ton of information there, and you can download a C compiler and get it to run DJJPP or something like that, the Jury C compiler. And so that was kind of messing around with that stuff way back when. And it's frustrating and slow process, and I probably learned a medium amount, but then when I went to college in the end, I was kind of seeing all the material in some sense for the second time, which made it much easier to integrate. I think that was probably the major benefit from it.
Yeah. And did you ever consider any other degrees, or if you couldn't do computer science, what do you think you would have done?
Good question. I considered computers and like engineering and computer engineering. I considered like mathematics maybe briefly, but when I was younger, I considered like law. I don't really know why. I guess I liked arguing with people. People told me I liked arguing with people. I like trying to reasoning things out and stuff. And so I guess there's some element of that. But that was maybe only like very briefly or something. And so I had pretty strong clarity that I wanted to do computers for a certain sense early in secondary school. Mm-hmm. I was interested in video games, probably wanted to be a video game programmer for a while, but yeah.
Yeah, and then after your degree, you worked in kind of software engineering for a while before deciding to go back and do a PhD. So what was your thought process there with the PhD?
So I did an undergrad, and I did graphics and AI modules in Trinity, and then I was kind of out of that, and I had been working doing software contracting for a few years and learned a lot, got to work over in California for a bit, and was in a software company with a bunch of classmates kind of doing contracting, and we tried build like software product, and we really didn't know the basics of product development, and so kind of like took a little bit of time out after that to figure out, okay, what should I do next? And was always kind of like I guess, intellectually curious and, you know, kind of mulled over the idea of maybe I should like go and do a PhD to learn a lot of stuff. And, you know, I spent a good bit of time reading about like economics, reading about artificial intelligence. And I came across this PhD program in UCD, was being advertised in called the Clique Research Cluster, using, you know, machine learning to analyze networks like social networks, biological networks, and, you know, this idea that there was like some commonality in the structure of these different networks. And that sounded interesting, and so I applied for that. And yeah, I just kind of, I guess, probably irrationally fell in love with the idea of going and doing research and doing a PhD and just getting to study something deeply for a while, you know.
So when you were going into the PhD, did you see a career in academia ahead of you, or were you thinking about industry afterwards, or didn't have any idea?
It's a good question. Like, it's always a difficult question for someone to answer honestly when they've like gone and worked in industry. Maybe they should have. Maybe like, to what extent are you a failed academic or something? I certainly from pretty early on in it, I wanted to go and work in industry rather than pure academia. I probably wasn't sure about that, and I've probably always been like a little bit torn. Like, I like the idea of academia. Like, there's a purity to being able to like, at least in theory, to be able to like concentrate on research, and, you know, you're not serving like the profit motive of a company. You are trying to like, you know, just figure out like, hey, what's the core ideas here? What's the important thing? What's the important contribution? But then, like, you know, the reality is probably never completely pure. Like, you know, you've got to get things published, and, you know, you've got to like follow trends and do all that stuff. I feel a bit silly telling this to someone who's actively involved in that at the moment. And so, you know, like, yeah, so, I mean, I guess, I think, like, industry has changed a lot. Like, you know, obviously, there's always, like, really great applied labs in industry, but I think wider computer science industry is doing a lot of really interesting work now. A lot of things that maybe would have been more in academia, you can do in, you know, a machine learning team at an industry or an industrial lab. And so I think there's interesting fundamental work to be done in a lot of different places at the moment. So I'm pretty happy right now with where I've ended up. I think we're doing a lot of deep, interesting intellectual work. And so, yeah, I'm very fortunate with that. Right now, I don't regret, you know, the switch to industry. And I think from pretty early on in my PhD, I kind of figured that was where I was trying to get to.
Mm-hmm. And would you ever see yourself returning to academia in the future, or?
I don't know. Like honestly, I'm not sure academia would have me in future. Like when you go to industry, you don't you know, you don't publish as much stuff,
Mm-hmm.
and so you know, you do maybe a lot of interesting work. Like I've done some groundbreaking work, or, you know, like some novel work, not like, yeah, some work that's like legitimately novel, but and like totally could have been published, but then you don't publish it for like strategic reasons or competitive reasons, and so. You know, like that's a downside to being in the industry. You can publish things sometimes, but, you know, you do have that like commercial imperative, that, you know, sometimes you patent stuff and you publish it, other times it's better to just keep something quiet. And someone else will eventually publish it, and, you know, research still moves on. But yeah, like that's the other side of the trade-off that you accept. And so, yeah, I mean, I think academia is really cool and really interesting. Potentially, I'd love to work in academia at some point in the future. But I found a niche in industry that I'm extremely happy with. And so, yeah, so definitely no immediate plans to try anything like that. I mean, there's also the issue these days of if you want to do work on AI, you do need resources. You need computation budget, you need data. Some of that stuff is easier to come by in industry at the moment. I think that's a challenge for AI. It's not an insurmountable challenge. I think there's cool academic work being done with not a huge amount of resources, but that has like major impact. So, you know, it's always complex. It's always a mixed bag. It always changes.
And if you were to give advice to someone who's finishing up a PhD and thinking about going into industry, what sort of things would you advise them, and what sort of skills from your PhD have you found were useful when going into industry?
So I think industry is a big place, and like there's a wide spectrum. And so, you know, if you are trying to work as a software engineer, a lot of software engineer jobs, it's a particular set of skills required. If you're trying to work on maybe a machine learning team, like doing applied research, or somewhere applied research meets engineering, it's different. So I guess I'll answer in that second category. What's useful? The ability to deal with a lot of ambiguity and a lot of uncertainty is extremely useful. The ability to like be comfortable with that. Like a lot of people who don't have that sort of academic training, they're in industry, they try and reduce uncertainty too quickly. They don't want to, like they're uncomfortable with it. Whereas maybe an academic is like, well, I don't know the answer to this question. I'm working hard to find out, but maybe it's going to take me a few years. And like, I think academia trains you to see the world more as it is. Whereas like in industrial settings, sometimes it's just about like speed, speed, speed. And like that can force people to reduce ambiguity too quickly. I think people who've had time and like narrowly research areas are a bit more comfortable with ambiguity. Confidence of like, staying the course, right? Like you gotta, if you're doing research, you're gonna get like knocks, you're gonna get setbacks. You gotta spend a lot of time feeling, I have no idea what I'm doing. I don't understand this at all. I thought I understood it and then I didn't. And then like time in research kind of teaches you to like persevere, to like, push through that. No, there may be light at the end of the tunnel. Maybe there won't be, but there may be. And so you get a certain, determination with that and confidence, right? Like after you've published research on things where maybe nobody has covered this ground before, I think that teaches you a certain confidence and determination that, in an industrial setting where a lot of people maybe are trying to ship software quickly and, they don't have the patience, it teaches it's good to like, honestly, to be bloody minded about something sometimes, to be like, no, I'm going to stay the course, I'm going to keep on going. Sometimes in an industrial setting, that's also a really amazing way to make progress, especially if you're trying to work on extremely challenging, stuff that's like very high risk, high return. And you need that sort of mindset to like persevere, get your fundamentals in order and, build a foundation and then move forward. And I think academic training, and certainly what I got in my PhD was really helpful with that. So, and then also like, it teaches you something about how much people know things or don't know things. It teaches you something about the production of new knowledge and sometimes how uncertain that is. And, to view it like healthy skepticism, frontier work. Like, maybe these people have a result in a paper and they claim it's amazing. And it's like, well, is it really true? Like, you got to go and do the work yourself. And that comes up a lot in industrial settings. Maybe we're using a new large language model and it claims to be amazing. And, I work with a lot of PhDs and, people are used to, taking no one's word for it, evaluating it from first principles yourself and, having the confidence to be like, well, maybe, and that's, so yeah, there's a lot of skills that are maybe not, maybe you might expect an answer more like, oh, data analysis stuff. And yeah, you learn data analysis. You learn a lot about randomization and, good kind of like, fundamentals of research. But for me, it's those kind of like softer things. You can teach somebody, how to run an A/B test or how to design a controlled trial or statistical rigor even. But teaching somebody like that sort of like patience and, confidence in the face of uncertainty and dealing with ambiguity, those to me are like the key skills that are really hard to learn unless you've got several years to work and grind away on a hard problem. And I think academia is great at that. And so, yeah, I hope that doesn't go away anytime soon.
Yeah. So after your PhD, then you kind of went out on your own with one of your fellow PhD students and started your own company. So can you tell us a bit about that journey?
There wasn't as much interesting machine learning work in Dublin back maybe 10 years ago almost. Yeah, about 10 years ago now when I finished my PhD. And I was like, I do want to work on like interesting things. And I was like, I was particularly interested in reinforcement learning. It just seemed like a fascinating area of machine learning at the time. And I was like, I want to work in reinforcement learning. Okay, how do we go about doing that? And then, that probably like married something else, which is that when we were in our PhDs, we'd seen a lot of people work on problems, let's say churn problems, right? So like trying to build supervised machine learning methods to predict things, like to predict who's going to cancel their subscription to a mobile phone or a software service or whatever. It's a important industrial problem, right? And there's this constant problem with churn, which is that people come up with these really good classifiers or regressors that like predict who's going to cancel. And then it's like, okay, what are we going to do about it? Oh, we'll just sort of throw those people over the wall and someone will call them up and offer them a new phone or offer them a discount or something. And like that's often the wrong framing of the problem. What you should be trying to do is figure out, okay, what should we do? We could like intervene. We can give this person a discount or no discount or, give them a really big discount. Which of those actions is the right action? And so that was a common industrial problem, but was being treated as supervised learning, but should be treated more as like a reinforcement learning problem. And so I guess those two interests kind of met. And myself and Conrad, one of my buddies from my PhD, decided to go start a company doing this. And we got a little bit of funding, a little bit of money from Enterprise Ireland. And we built a service to try and do contextual bandit algorithms. And we ended up applying this to like website optimization because it's a very similar problem to those other ones I just mentioned, but it's like you can build a service that a startup might use, and then you can actually build a startup yourself that other small companies will adopt quickly. If you're trying to build a little startup and sell it to enterprises, even if you've got the best product in the world, their sales cycle is so long that they won't adopt it. And so like, I'd say to anyone trying to build a startup, there's a lot to be said for thinking about building products that small companies, quick companies can adopt. So yeah, we built that for about a year, maybe a little over a year. We were sort of like not getting, we had probably some like product mistakes. We were probably too early for what we were trying to build. And we built some really cool technology. We did have a product, we did launch. We had like early traction, but not enough that things were going well for us. And we got an acquisition offer from a company in California and ended up taking that in the end.
That's brilliant. And can you think back, you mentioned there about mistakes you might have made. Is there any that stick out and what you've learned from them?
I mean, that's a long topic because there are many, many mistakes. Every product I work on has loads of mistakes in it. Specifically in that particular startup, mistakes we made. We were probably a little bit early in terms of our timing, trying to build these contextual bandit algorithms. Probably like 2-3 years afterwards was probably better timing for that. And so like, that was a mistake. It's extremely difficult doing product development to get the timing right. It's almost like you can almost be too early or too late. You can pretty much never hit it right on time. But still, that was maybe doing something that wasn't as novel and wasn't as timing sensitive would have been better. Honestly, probably we also like taught too small. That's probably something that I would say. I think at the time I felt we don't have very much traction. Our bank balance is slowly failing. We've got this offer. We should go and get acquired. And it was a good offer. But like retrospectively, when I look back at it with like more experience working in product and as a product manager, I'm actually given how early we were, we actually did have a lot of traction. Maybe we had 100 users or something, like 100 businesses or individuals. Not many, but now I look back at it with my more seasoned product hat and I'm like, wow, that's a lot of traction. A lot of startups don't get that much traction. And probably what we should have done, or an alternate approach would have been to try and like raise money based on the back of that traction. And probably just didn't really understand that well enough at the time. Now I have seen more products through their life cycle, and when a product is early in its life cycle, even a small amount of traction can actually represent quite a lot, because it's when you're early, you're like the amount of people even potentially interested, the market size is just so small that like getting tens or hundreds of people can actually be a big signal of traction. So that's probably a mistake. We made another mistake, which is the classic mistake you make coming from academia into industry, which is you build too much technology and you don't like spend enough time on marketing. Probably a startup you spend 50-50. But we did spend time on marketing, but we definitely made a decision to invest more in technology. And that can go either way. I know talking to I guess, an expert person in the Irish ecosystem about this at the time, and he was kind of like, hey, you know, the reason I'm here talking to you today is because you made a technology investment. You did something interesting with the technology that stands you out from the crowd of other people who are just doing marketing. So, you know, it's hard. Starting new startups, like trying to get a startup off the ground is hard. Trying to get a startup that does something new and new technology is incredibly hard to do. It was a great learning experience, and you know, we had a reasonable outcome. We, you know, went over to work in this A/B testing company, Optimizely, and we had some impact there, and managed to ship some bandit algorithms at scale, and that was pretty cool. But yeah, there's always mistakes. Are they mistakes at the time, or are they mistakes retrospectively? Probably both. It's always hard to know.
Yeah, that's really interesting about the kind of balance between marketing and tech, coming from obviously a more technical background yourself.
Yeah.
So now obviously you are working in Intercom. So I'd love to hear a bit more about what your job at Intercom is and what the company does as a whole.
Got it. Okay. Yeah. So I've been in Intercom about 6 years. Intercom is, you know, it's kind of like a B2B SaaS company. So software as a service, our customers are businesses. And, you know, predominantly like our customers are more like, you know, we have a lot of like small and medium businesses or mid-market businesses. We have some very large enterprises, but the company would tend to skew more for like mid-market, small, medium businesses. They have customer support challenges, right? People are coming along to go to, you know, immediate, like an e-commerce website, and there's been a problem with their order. Like, has my order shipped yet? I haven't received it. Intercom builds this messenger you might see in the bottom right-hand corner of the website. Someone can click on the messenger and kind of, you know, ask that question about their order. And then we build this whole sort of set of software behind that, where it's like, hey, we're going to go and, you know, have a 10-person support team or 100 or even 1,000-person support team, you know, answering these questions kind of quickly and efficiently. And, you know, where does AI come into that in machine learning? And I joined the company about 6 years ago to start trying to build, you know, machine learning, trying to build like bots that will, you know, maybe someone's asking a common question. They're saying like, how do I submit my meter reading to a utility? And 50% of people coming to the website are struggling with this very basic thing, and they can't find the instructions to do it. And we have this little bot that will use natural language processing to realize, yeah, that's what they're asking. They're not asking something else about their meter. They're not asking, why is my meter broken? They're specifically asking about a meter reading. And we've got to use natural language processing to do that. And then we'll give them the answer, and maybe we'll enable our customer to set something up to talk that end user through the process, handhold their way through the process of resolving that. And so, yeah, I've been working on bots and kind of machine learning tech like that at Intercom for about 6 years. Shortly after, I kind of joined to start the machine learning function in R&D. And the first product we shipped was this like resolution bot, which attempts to do that. Yeah.
And I suppose the landscape for natural language processing and chatbots has changed quite a bit since you first joined Intercom.
Yeah.
How has the kind of advances, I suppose, like the likes of ChatGPT over the last year, how has that changed your work and the work at Intercom?
So I remember when I joined Intercom, I hadn't been that interested in natural language processing. And I was kind of like, okay, I'm really interested in reinforcement learning, and you know, that's where the big breakthroughs in AI are going to come from. And I joined Intercom, and I was like, okay, well, it'll be good to learn about NLP, you know, and you know, the same machine learning tactics apply, and I'll learn more about it and work in this, and you know, built these generation 1 bot. And you know, the first bot we built was all like, you know, traditional NLP techniques, and we ended up handwriting sort of a BM25 inspired, you know, TF-IDF style, like inspired, you know, thing to figure out when it's going to answer a question properly or not. And, you know, time passed, and, you know, neural networks started to get good, these big BERT models and models like that. And, you know, we were kind of looking at those and benchmarking them, and it just didn't do as well as our hand-coded, you know, expert algorithm. But the direction of travel was interesting, and another year passed, and suddenly some of these networks like Muse, Multilingual Universal Sentence Encoder, were starting to like outperform our, you know, hand-coded, you know, domain-specific thing. And we were a very early adopter of those networks. I think some of them were published, and we had them in production a few months later. And we were like building what you'd now call a vector database approach to do that. And, so like we're sort of pretty close to this neural network thing. And maybe about 2-3 years ago, we started to have a really early beta relationship with OpenAI. And we used GPT-3 and we tried to see, is this good enough to put in production? We're like, oh no, it's not as good as these kind of like neural networks we have, the more general BERT neural networks. And it's expensive. Like, why would you use this? Like, why would anyone use a large language model, That's probably not very interesting. And time passed by and, we kind of like OpenAI every now and again would like, be releasing things. And we were kind of keeping an eye on it, but not really close. And then almost exactly a year ago, ChatGPT launched. And it was like, whoa, this has come on a lot in the last year. Oh my goodness, this is going to like completely change your industry. And that was like just this watershed moment for us. Loads of people in the company, on my team, but even like execs in the company and stuff were like up at night in Slack, like, the messaging service in the company, like, oh my goodness, can you see this? Wow, this has changed. It's suddenly this stuff is just so much better at like handling natural language. And, Intercom's domain is like people chatting to each other on the internet. It's kind of informal, traditional techniques don't work so well. And like ChatGPT was just able to really easily parse all these things. And Text-to-Vinci 3, the model, so we still had API access, so we could like start playing with Text-to-Vinci 3, and we were like, wow, this is amazing. And my team took a week to kind of come up with a synthesis of this to benchmark it, and like we were like, wow, this is going to change things for us. And very quickly we decided we were going to ship products around that, and it was just going to be a watershed moment for us. Yeah.
And can you pinpoint any particular example or like time that you were using ChatGPT in those early days where you thought that, kind of, wow, this is really something different than we were dealing with before?
Yeah, I mean, there's a lot of examples. Asking it like the same things everyone else was doing, like literally on the first day of release, like asking it to like write poetry, write this in the style of that, and essentially trying to push it. As a machine learning person, trying to push it out of sample, trying to push it to do tasks that definitely weren't in the training data set because you just made them up. They're so novel. And then seeing it still do a good job there. It's not just regurgitating stuff, it's memorized. There's at least some level of synthesis there. And, in the company, Intercom, we had this challenge, which is that customer support representatives, often before they hand over a case, like they're going to get a specialist, they have to write a summary of the case. And people in our inbox, maybe they could spend like 5 minutes talking to a user about the conversation, and then 5 minutes to write a summary, right? And we were like, oh, all the data's there in the conversation. Could we write our own summary? And we had tried to do that. We had done a survey, Cahill on my team and some other people on the team had done a survey of, the available state-of-the-art natural language processing techniques about 6 months before ChatGPT launched. And we were like, if you're trying to summarize a big document, these techniques work pretty well. BERT, T5, all these Google models work pretty well. But, if you're trying to deal with like messy human conversation, that's a lot harder than summarizing a well-structured document. Machine learning is like a long way away from doing that. And then ChatGPT was able to do summarizations of these messy conversations almost out of the box. We were like, wow, that is amazing. People have been working on this problem for decades. Summarization, the state of the art, is so raw compared to this for our domain. And so we were like, wow, that's just a feature that I made the call. We're going to ship summarization. We're going to ship some other features. And we managed to ship those very quickly. Like ChatGPT launched at the end of November. And by Christmas that year, our own internal customer support team had like a live automatic summarization feature that they could use. And we shipped those to customers and went away for the Christmas holidays. Our customer support team worked over Christmas. All the skeleton crew doing that. And like, so we had data on their usage of this in January. We were like, this looks good. And then shipped it to customers and did a launch, like a kind of a public beta launch by the end of January with testimonials from customers who've been using it for 2-3 weeks. So we executed very quickly on that because we just thought this is huge. This is a really big deal for us.
Yeah. And I suppose there's two main ways that you can, tune language models, whether it be prompt engineering or fine tuning. I'd be interested to hear your thoughts on when one is necessary, or what sort of problems need fine tuning, or when you can just get away with some
Yeah,
prompt
we're getting
engineering.
into the details here. So it's a moving target. When one is necessary is a moving target. So, you know, uh, 2 years ago, everyone would have given one answer, and now they'll give a different answer. And like, GPT, like the idea of, GPT-2 or GPT-3 was always that like, hey, you're going to go and you're going to like produce this generative model, and then, it's going to be foundational, and then you're going to go fine tune it for any particular application you have. And we played with fine tuning models in that time frame. But there was no idea of like prompt engineering or even prompting the model for like the first wave or two. And then like now with GPT-4, it's like, oh, you with the right prompt, like it follows instructions so well, even better than GPT 3.5, you can just put a lot of intelligence in the prompt. Tell it what to do. It'll probably follow your instructions. Maybe you don't need to fine tune it much at all. So it's very dynamic. It's very moving. I would say right now, the state of the art is probably that like, for adding new data to the model that is bigger than can be contained within a prompt, so that the model is able to make inferences across that data set, you sort of need to like fine tune the data into it, and probably pretty deeply. For doing like stylistic things like tone of voice, things like that, you can do a lot in the prompt. But yeah, that's for like the largest model. That's for like GPT-4. Smaller models, the trade-off varies. So I would almost say like you've got to have an application area in mind, and you've got to just have a model in mind and then just test on the model. And there's like a full spectrum of things between prompt engineering and between fine-tuning. There are some things that with a particular application that we spent ages trying to prompt engineer GPT 3.5 to do, and we just couldn't get it. We just couldn't get the trade-off we wanted. And then we were able to we spent ages prompting it to try and do that, couldn't get it. And then we were able to fine-tune it quite quickly to do that. So yeah, it's not this is an early, poorly understood technology. It's changing very rapidly, and we just, you've got to just try things. And this goes back to your question about, research skills. Like it's very researchy. It's very much like you got to try things. You got to have a test harness, a benchmark, positive. You got guardrails to watch when it does something you don't expect, and you got to just try it and do science and see. There isn't really any best practice because it's just so new and it's changing so rapidly.
Yeah, and obviously when you were working for your own company, you had to develop a lot of product skills, obviously. And how do you think that experience has helped in your role with Intercom and kind of moving up the ladder there?
I think it's helped a lot. So when I was in my own company, we built new products and we learned a lot and failed a lot and learned through failing as well. I learned a lot about product. And then when I worked in the acquirer of ours, Optimize, I actually worked as a product manager there for about 2 years, almost 2 years. And that taught me a lot. There was a really good product team there of like very experienced product managers from other companies. And I got to work with them and I learned a lot about product. And that's been really useful. I would say like anyone who is going to try and, do well as I would say even, a very senior engineer, as you get more senior, you want to learn some product skills because, there's this mental model that some of my coworkers in Intercom use, which is that, software development and product development like has all these different disciplines, and like it's almost like this in the center of all the disciplines is the product. If you're a designer, as you get more and more senior, more and more of your energy kind of goes to this convergent thing you're working on in the center. So I would say if your background is engineering, if your background is science, but you want to work in product development, you want to learn product skills. And a lot of the value I bring to Intercom is by being able to like understand, okay, what's the product, what's the requirements, what's the strategy, and what's the technology, and like where these two things intersect. And there's real skills in both, and being able to like mesh these two things together can save you a bunch of time basically working on real applications. And people on my team, as they get more senior, I try and make sure that they learn the product side of things as well. Some folks in engineering or maybe science be like, oh, the product thing, like they don't like their product manager, or what their product manager does is mysterious to them, and sometimes they react negatively to that. And I would always say, no, that's the wrong attitude. You know, the product is what you're trying to do. It's you're trying to ship stuff. You're trying to learn things, but you're trying to learn things to be able to ship more stuff in future, to have better products for real people that go and use them. And so the product skills are not something you should ignore or look down on. They're incredibly valuable, and you know, you can unlock a lot more valuable. But I think this is true if you're doing a PhD as well, right? Like you shouldn't just be thinking about like the academic stuff. You should be thinking about like how it fits into the overall problem that people are trying to understand. Like what's, you know, you don't just go off and do something because it's deep and technical. You do it because it's deep and technical, but will help move forward progress. And if you don't do that, you spend a lot of time working on some branch that gets pruned. Maybe you go very deep on some branch to apply some very complex way. And you're laughing, Rian, maybe you've seen that happen. But yeah, and you know, it's you never know exactly how it's going to turn out. But you want to have that sort of like meta, you know, like that higher level thing, like, is this useful or not, you know? So,
Yeah. And as you yourself became more senior, how did you think about balancing the time between kind of being in the weeds of the programming versus, you know, the, I guess, the activities that come with leadership and
yeah.
product thinking?
And so I struggle with that. I'm struggling with that right now. I think a lot of, you know, technical leaders or leaders from technical backgrounds do struggle with that. Why is it a struggle, right? Well, you know, it's not high leverage to just be like writing code yourself, right? And so what you want to do is you want to try and like work maybe closely. This is, you know, the first way of getting leverage is you work closely with maybe engineers who are writing code, and maybe you're helping with like overall technical direction. But you're still very close. You might not be doing the extremely low level implementation, but you've a really tight idea of what's going on. You're reviewing code, you understand the algorithms in depth. And then like, you know, you get to the point where you're like, oh, well, that's not a very leveraged activity. You can get more leverage by, you know, going up a level. And, you know, people do that. But the catch is that if you go up too high of a level of abstraction, your judgment starts to become stale. Your technical understanding starts to become stale. You start to give people, you're in this position of leverage, and you're like giving somebody the wrong technical steer. And then you're a disaster. Like you're not doing a good job because you're trying to act with leverage. Okay, what do you do? So one strategy is you just kind of recuse yourself from those technical decisions. And I think if you do that, you stop to become a technical leader. And like the other strategy is that you try and maintain enough awareness to like maintain your technical leader and maintain your good judgment. And you have some advantages. You're getting input, and you know, you're working with people who are more hands-on. And so like, you know, you can maintain that. The kind of leader I want to be is a technical leader. I want to maintain that, you know, deep understanding of what's going on. And so I spend time that, you know, has opportunity cost to try and do that. And maybe that, you know, if the company I was in was a 10,000 person company, maybe that would eventually like put a limit on, you know, like how high a level I operate in that company. Or maybe not. It's hard to know. But I generally think of myself insofar, like a lot of tech companies resolve this because they kind of say like, hey, there's like a CTO track and there's a VP of engineering track. And you know, if you're an engineer, maybe you're a senior engineer, your next job could be like more of a manager, in which case you're heading more for the VP of Eng track. Or your next job could be like a staff engineer or a principal engineer, in which case you're heading more for the CTO track. And I personally would try and stay on the technical of those two tracks, and that's very much my ambitions. And then there's the struggle of finding time to do that, especially in AI. I think there's nobody in machine learning or AI who isn't struggling to stay current because things are just moving so fast. And this is a problem in industry, and it's a problem when so much is moving so fast, and also when you're trying to run teams and stuff. And yeah, so this is absolutely a challenge. And you know, something I intend to continue investing in. I have a sabbatical coming up sometime soon. I intend to spend a lot of time playing with LLMs at a slightly lower level than I've had an opportunity to in the last year, say. But yeah, it's a challenge. Like, you don't want to get stale. You don't want to become a bad technical leader where you think you still have the understanding of what's going on, but it's stale and you're giving people wrong steers. That's worse than somebody who just commits to being purely managerial. And so that's absolutely a pitfall, and it's hard. There's opportunity costs everywhere, and that's always the way it is in any fast-moving company.
Well, I've heard in some other talks you gave, you had some interesting takes about kind of where the future might be with AI. Particularly, I remember you said in one talk about, UI might be kind of generated on the fly by AI within, a few years. And then the demo that Google gave with Gemini, I don't know if you saw, had an element of that where there was UI kind of being generated on the fly. Right. So I guess that one came true.
Yeah.
But I'm wondering, do you have any other kind of predictions or thoughts about where we might be headed?
I mean, predictions obviously is a fraught business. I think, in terms of user experience, like, you can always just look at humans and, how do humans ideally relate to each other, right? And like, there's thinking tools you can use for that. And I always say, if you want to figure out what an optimal user experience for a human is, look at how let's say someone who's got like a personal assistant, how do they interact with the personal assistant to book a flight, right? That's probably what they're going to do. And, if it helps them to draw something out, like if they're working with a designer, if it helps them to draw something out for visualization, they'll do it. So I think there's certain things you can extrapolate there. And yeah, I think the idea of like talking to computers, I think voice is such a natural interface for us. We'll probably talk to our computers. And yeah, I think they will maybe render things on the fly. Generalized predictions about the future is extremely hard at the moment. I would say that large language models are very interesting. Like, I have an opinion which not everybody shares, but I think LLMs are doing something that can best be described as reasoning. I think when I look at GPT-4, and I've got to use GPT-4 a lot, it's either reasoning or it's doing like a close enough approximation of reasoning that you can use it to build effective things that reason. And so I think that's amazing. I think a lot of people either don't agree with that or, in my opinion, just haven't deeply internalized that, because it's such a radical thing that you can just train an LLM at scale and it starts to reason. And I think if you believe that, or if you think that's likely, let's say you think that's 50% likely that it's at least reasoning at some level, well, there's 50% chance then that something absolutely wild has just happened in technology. And I don't mean that it's generally intelligent or sentient or anything, but just that, we spent a long time trying to get machines to reason, and now they're doing something that can be described as some maybe elementary, maybe imperfect, but reasoning. How far will that go, right? Like when people put 100 times the computational resources and they get way better at training these things, how far will that go? I think we don't know, and I think that's fascinating, and that's probably the single most interesting thing that's happened humanity, in my opinion, in a very long time. And it's always possible to get a shock. It's always possible it's like, it was just a really good trick. We were all taken in. Things we thought were out of sample weren't as out of sample, or it was just some schematic matching. Like, it developed some understanding of language that was, that fooled us to some extent. This is always possible, but I think there's a good chance that we'll look back on this and be like, yeah, we started to finally build machines that could reason intuitively in a way that people couldn't for a very long time. And if that happens, that will be obviously hugely significant. That'll change so many things if it continues to scale. And so yeah, I think that's the most interesting thing. And yeah, let's see what happens.
Yeah. Obviously, I suppose the really high-performing language models now are in the hands of a few of the big companies. So do you think that, or in Intercom as well, is there thoughts there about maybe looking to train your own models or reduce dependency on the kind of API providers?
Reduce dependency on the API providers we're not so worried about. Like, OpenAI has been a good partner to us, and then there are many other API providers as well that are offering other APIs. Anthropic, we've had some access to Anthropic's APIs. Anthropic's language models are really good as well. Obviously, we've all seen Google recently has claimed good performance with Gemini. So open source things. Mistral just dropped another model in the last few days that people certainly are saying is performant. We'll have to get our hands on it and see. It's an extremely rapidly evolving space. I'm not too worried about dependency, strategically at this point. However, if there's things we can do where we can like fine tune an open source model and like build better products for our customers, then yeah, we absolutely want to do that. And Intercom, we're investing a lot more. We're like really increasing the size of our team here in Dublin. We're looking for people to come and like do this sort of like really cutting edge work, training large language models, certainly fine tuning them. Will we ever end up training something from scratch or not? I don't know. There are interesting papers out there, textbooks is all you need, and like other papers like that, where people have taken, models and gotten really good performance in certain tasks by giving them very well curated data sets. And so I think it's very difficult to say, it's very difficult to limit, to say, well, we definitely won't be doing X or Y in a year or two. The technology is moving so fast. I would say like we're trying to do more and more. We think this is transformation. We think customer support, this area we work in, is going to be completely changed by AI. There's, just humans spending lots of their day just answering simple rote questions again and again. Most customer support teams are like under-resourced. If we can have AI answer all the simple rote questions, it's transformative for this really quite big industry. So Intercom's willing to invest a lot in trying to make that happen. That includes training our own models, certainly fine-tuning them, but we'll kind of go as deep here in the stack as we need to try and like invent the future of customer service and customer support. We'll see how that goes,
Yeah. And obviously with AI becoming such a big part of the business at Intercom, have you found that that's, I suppose, made your life a little bit easier in terms of pitching your, ideas and products and things like that?
It's definitely made Intercom willing to take a big bet. Like I think the CEO is on record as saying, hey, we're betting the company on AI, So like the company is making this really big bet. And so my team is expanding a lot, like probably quadrupling in size, versus a year ago to where it'll be in a year's time. That's a big change, maybe more, maybe 5x or 6x, and so that's a lot of work, right? You've got to like scale a team. It's a lot of challenges. It's a great team. I get to work with great people, so I'm sure we'll rise to it. But there's a lot going on, and I think anyone working in industry and AI, like so many businesses are looking into going like, wow, this is going to change your business. This is going to disrupt our business. We have to do this first, or someone else is going to disrupt us. So it's definitely, it's a busy time. And the clued-in companies are reacting to this in a serious way. If you are in an industry that you think is going to be disrupted by AI, and if your company is like, engaging with that, if it's forward-looking rather than just managing its book of business, so like tech startups hopefully will be in that category. It's top of mind for people. People are like, wow, how do we make sure that this disruption happens and this goes well for us and well for our customers and not badly. We don't turn into an also-ran. And it's a time of massive technological disruption. Internally, like the things I sort of say is like, hey, by default, we should think of ourselves that it's the internet. It's the mid-90s, and we were running a bookstore, and we didn't. Now there's this new guy, and he set up an internet bookstore, and we're like, obviously we aspire to be the Amazon in this story. I'm sure most companies do, but we should be paranoid that we won't be. And like everyone in technology should be really paranoid about like disruption and getting your business disrupted. Some companies more so than others, but customer support absolutely feels like we were doing AI things for the last 5 years, and that's because we thought that our space was amenable to AI. Our space has suddenly become a lot more amenable to AI, and that is really good for us, but also really competitively, we have this huge opportunity. If we don't take it, somebody else will. And so it's a busy time. It's a busy time across a lot of industries that feel close to the initial impact of AI.
Yeah. And I suppose even for industries that aren't necessarily dealing with kind of unstructured text data, there's still a lot of opportunity there for increasing productivity. So do you see that the workplace is going to change for a lot of companies, even if they might not realize it yet?
I would guess so. I have deep expertise, I guess, at this point in customer support and customer service meets AI. So I'm certain it's going to change in a major way. And we've shipped products that we've this product Fin or GPT powered chatbot, and people ship it, they turn it on, and it answers 30%, 40% of the customer support questions on day one, and like it does a good job. Most of those are real answers, and that's huge. The previous generation, you need to do all this work, and so that's just one industry like that is going to get transformed by this. Even just if the technology didn't get any faster and any better, and like it will, almost certainly will. So like how broad is that? I don't know. I think you've got to analyze it on an industry by industry basis, and then you've got to look at like through multiple lenses. One lens is at the power of GPT-4, right? What's going to change? But then another lens is like, what if there's a GPT-6 or a GPT-8? Like over 5 to 10 years, how much does this change? And I think it's really hard to find industries that won't massively change over 5 to 10 years. Certainly, any sort of technology industries, any sort of office work, so much office work, so much technology work is going to change 5 to 10 years.
Yeah, definitely. And is there any part of you that's kind of worried about it? I mean, there's a lot of people who are concerned about AI and, perhaps, even from a kind of loss of jobs point of view, or from sort of an AI takeover point of view as well. But
yeah,
I wonder what your thoughts are on
I think those are two very different discussions, and it's sort of weird that they get coupled, because it's like one concern is like, we might have job losses, and the other concern is like, AI might take charge of the world. And I think you've got to address them separately. And I think surely people in future with the perspective of history will look back and they'll be like, why did these things get bundled together in the discussion? Like in terms of the loss of jobs piece, right? Like all technology that increases efficiency at least transforms jobs, right? That's been the case, the mill, like the water mill, meant that people, ultimately weren't threshing, corn into flour. And, so there was a lot that damaged, there was jobs lost. But then there was other important stuff to do, and people did those important things instead. Another kind of thinking lens is like, I remember cloud computing and Amazon Web Services, and everyone said, this is going to destroy software jobs. It used to be the case that I had to have a team of 10 people administering all my databases on my server racks. And now I just pay AWS for it. But it didn't destroy software jobs, because it meant that like the companies could use all those programmers to like build more applications just for them. And jobs changed around a little bit, but overall there was a lot more software jobs. Sometimes doing things that make something more efficient means everyone wants to do more of it. It's like Jevons paradox, right? So maybe that'll be the case with AI. Maybe there'll be a lot more jobs because we can do everything a lot more efficiently, and so that's a possibility. Weighed against that is like a fast technology change can disrupt jobs before people have time to like retrain or to go up the value hierarchy or whatever. I don't think anybody knows exactly how that equation works out, but I'm optimistic that overall, if it's like, hey, more technology means we don't need to do as much rote tasks, that's a good thing, right? And like I think with our current level of technology, I think overall it's going to be good for people. Now, you get to your second question of like AI takeover and stuff, right? The kind of the science fiction scenarios. Like I don't rubbish those scenarios. I take it like seriously that like, generally intelligent systems might be possible to build, and we don't know how hard or how easy they are to build, and we know progress is moving extremely fast. So I feel good when let's say in America the White House had this like executive order that if your training model is above a certain size, you have to get in touch with them. And like I think that's good. I think there should be some like regulation on it. I don't think it's going to like, it's not that like, I don't believe anyone who predicts like, oh, and Tuesday the 15th, 2026 is going to be a general intelligence. We don't know. But it's I think it's worth taking seriously. I think anyone who completely rubbishes, and like says there's no way this will ever happen, there's no way AI could ever be dangerous, I don't think there's evidence for that. I don't think there's evidence that it's imminently dangerous. I don't think there's evidence it'll never possibly be dangerous. And so I think people should be cautious about it. And I wouldn't like ban things, because I think if you do that, you'll drive it underground. And so I think, the whole proceed with caution thing probably feels good to me. But but with a degree of caution. If people figure out how to make more intelligent systems, we should start being real cautious. And I don't know if we're close to that or not. I don't think anybody knows.
Really interesting, and I mean, the future, we'll have to wait and see, I suppose. But it's been a pleasure, Fergal, and really appreciate your time today.
Rian, thanks very much for having me here, and really great to come to UCD and talk about all these interesting topics. Thank you.
Brilliant. Cheers.